Okay, so today we're looking at the derivative of inverse functions. So we're reminding ourselves what an inverse function is from Year 11 content. So our learning intention is to gain the knowledge of how to differentiate inverse functions. So we successful if we can calculate the inverse, differentiate that inverse function, and actually apply this fact that dy over dx times dx over dy equals 1. Or alternatively, dy over dx is equal to 1 over dx on dy. Okay. Let's do some examples. If we have this function, f of x equals x to the power 6 minus 1, we want to find the derivative of the inverse. So this is saying that y equals x to the power 6 minus 1. Now, from the Year 11 course, to find the inverse, we're going to swap x for y's and vice versa. So we get x equals y to the power 6 minus 1. I'm going to make y the subject, so it's actually going to be x plus 1 equals y to the power 6. So y equals x plus 1 to the power of 1/6. Okay. So now we can find if the derivative of x plus 1 to the power of 1/6. Okay. Which is 1/6 x plus 1 to the power of negative 5/6, which can also be written as okay. Alright. Let's look at another example. Let's differentiate the inverse if f of x equals the square root of x. So let y equals x to the power of half, swapping so we get x squared equals to y. So the derivative of x squared equals 2x. Okay. Alright, so we want to show that dy over dx equals dx times dx over dy equals 1. Okay. So y equals x cubed, right? If I wanted to find the inverse, okay, we get x equals y to the power of 3. So x to the power of a third, or the root, equals y. Okay. So if I want to find so dy over dx in this situation is going to be 3x squared. Okay. Now, d over dy of still using this, of using this rule, y to the power of a third would be that. But we're going to replace what y is with x to the power of 3. So dx over dy is going to give us x squared. Okay. So now bringing this together, we're going to get 3x squared times a third x squared so that's going to be minus 2/3. Yep. That gives us 1. Okay. Alright, we want to find dx over dy of the inverse function of x if we've got 3 of x sine 2 of x. So if we've got y equals 3x sine 2x, we're going to swap the x's for the y's. Okay, and if we want to find dx over dy, in this case, I'm going to let u equal to 3y and v equals sine 2y. U dash would be 3 and v dash is going to be 2 cos 2y. As this is a product rule, dx over dy equals 3 lots of sine 2y plus 6y cos 2y, which you can factor out of 3. Yep. And there's your answer. Okay. Last example. Find the gradient of the tangent at 0, 1 of the inverse function to y equals x, y. So if y equals x log x, then x, y log y. We want to find dx on dy of y log y. So let u equal to y and v equals to log y. It's a product rule. Oh, sorry, log u. No. Yep. It's product rule 1 over y. So dx on dy is log y plus 1 over y. So y over y is just 1. And there's your answer. Oh, so we need to finish off the question. The question says, find the gradient of the tangent. So when we're looking at when x equals 0, what we're going to do is sub in that place for y. So we get dx on dy. Oh, sorry, y equals 1. Sub in 1. Log of 1 plus 1. I get solution of 1. And that's the answer. Good luck.